Hello again.
Hello. What are we going to be talking about now?
We're talking about torque now.
Torque. All right. So what is torque?
Torque is simple. Torque is rotational force.
Okay. So when you say rotation, you mean like a wheel or like an arm or?
It's a lever. Think of a lever.
Okay.
A lever arm. Think of a wrench. As you rotate a wrench around, you're generating torque. You are applying force in a rotational motion.
Okay. So torque is a kind of force.
Torque is a type of force.
Okay.
This is absolutely correct.
All right. So how does the radius of that lever arm affect torque?
A little bolt right here that I need to rotate in. Okay, I've got my wrench. Anybody that's ever worked with tools knows in order to generate more torque, you want to have a long lever arm.
Mm-hmm.
You want a large radius. And by radius, we mean the center of whatever it is that's rotating all the way down to the edge of your tool.
Right.
Okay? So the longer that arm is, or the greater the force applied, the more torque you're going to generate. So if you look at the formula for torque, fancy T, is equal to force times your radius.
My dad used to always call this a cheater bar. Whenever we had a bolt that was stuck, we always got the really long pipe wrench to go on there, and just so that way we had a really long bar to get more torque on it.
Okay, so the longer your cheater bar,
yes,
the more you cheat.
Right.
Because the easier it makes it.
Yes.
Another way you can think of this, think if you were trying to open a door and you're pushing really close to the hinges, it's going to be really hard. You're going to have to generate a lot of force in order to get enough torque to open that door. Whereas if you open the door closer to where the handle is, it's a lot easier because you've increased that radius. You've increased that lever arm.
And that's why we put the handle on the other side as the hinges.
Makes good sense, right? Yeah, we try to make good sense. Okay, so there's clockwise versus counterclockwise torque. Go ahead.
So we always think of clockwise torque as being negative. Clockwise torque, you can remember this as I never seem to have enough time to finish everything I want. So I always think the clock is working against me. So clockwise is negative. Clocks are bad. Counterclockwise is going to be positive.
That's your positive torque. So rotating in that direction.
Right.
It's unwritten rule is positive. Okay. Static equilibrium. This is when your objects are not accelerating or rotating. So you're applying the force and nothing's happening.
Right. So that's when the bolt is still stuck. I've got my little bitty short wrench. And I'm trying to take that oil plug out and it just won't move. So I got to go get the longer wrench. So it's in static equilibrium until it starts moving.
Yep. No rotation.
All right, so I'm still kind of confused on this. Let's work some guided practice problems. Some torque guided practice problems.
So here's our formula.
So it is torque equals F. What is F?
That is your force.
Force times R, which if we're dealing with something kind of related to a circle, it's going to be the radius. Okay? So the first problem says find the magnitude of the torque produced by a 3.0 Newton force applied to a door clockwise at a perpendicular distance of 0.25 meters from the hinge.
Okay, so let's list what we have. We have force.
Right. Which is 3 newtons.
3 newtons. Okay. We have
a distance, which is going to be the radius of this particular torque problem.
0.25. My point's not very dark, but it's there. There we go.
And we're solving for the magnitude of the torque.
All right. So we have force, we have radius, we're looking for T, or torque. If you look at our formula, all we have to do with these two variables is
multiply.
So 3 newtons times 0.25 equals 0.75.
Right.
What are our units for torque?
NM.
NM. So we're multiplying here. We're keeping these numbers side by side to multiply. So you'll keep your units side by side in your answer. So it's the Newton meter. And then
Now it says it's clockwise. So if it's clockwise, we said that's going to be negative.
So negative 0.75 Newton meters for torque.
Right. Okay.
Cool. All right.
Easy enough. Use that triangle for you. If you are solving for torque, which is on top, you multiply the two things on bottom. If you're solving for F on bottom, take the torque divided by the radius. All right. And now let's take a look at the second problem.
Okay.
Pendulum consists of a 30 Newton point mass hanging at the end of a long string that is connected to a pivot point. How long is the string if it requires 45 Newton meters of torque to move it at a perpendicular angle?
Okay.
Okay.
So we still have the same formula, same triangle.
Right.
Let's go ahead and list what they give us.
Right. So they give us 30 newtons, which is going to be our force.
Got that.
And they give us 45 Newton meters, which is going to be my torque. So that means we're solving for how long the string is, which is our radius. Okay. So now we're looking at our triangle. We're solving for the radius.
Solving for radius.
So we've got torque divided by friction.
So torque is on top. 45 Newton meters over our force, which is 30 newtons. So 45 divided by 30 is
1.5.
1.5. So this is our radius. Radius is a distance. If you look at the units right here, our newtons are going to cancel. So all we're left with unit-wise is meters. And that makes sense. If radius is a distance,
right,
meters is a distance unit, that's what our answer is going to be in.
Okay.